Vehicle-to-grid is slowly shifting from pilots to commercial offerings in Europe. In the UK, the Park and Flex study explored how long-stay public car parks could turn EVs into flexibility for the power system, while Copenhagen has rolled out a commercial vehicle-to-grid hub designed to provide grid support and ancillary services. So what happens if we bring that concept to Australia's grid? Australia's National Construction Code has created a platform to accelerate public charging. Under the 2022 NCC, new car parks must include dedicated EV charging distribution boards, and those boards must be sized so future 7 kW chargers can be installed across a share of bays depending on the building type. While EV-ready infrastructure is becoming standard, EV-ready does not automatically mean EV profitable. Let's see why. Now, picture an airport-style long-term car parks. Cars arrive early in the week, plug in and sit there until they're scheduled to pick up days later. In that setting, fast charging is not a requirement since we have time on our side. A low-cost, low-power 7 kW charger can deliver the required energy, and the long dwell time gives room to shift charging away from expensive hours and respond to network and market price signals, for example. In Gridcog, I've built a project model with two scenarios, where we'll investigate what these long-term parking providers should do with its current and exploited EV charging distribution board. The first option is pay-as-you-go charging, using 10 7 kW chargers and charging smartly. We use the flexibility in dwell time to control when energy is taken from the grid, helping keep network charges low and making the most out of time of use tariffs. For the second option, the parking owner is putting these dormant EVs to work by installing 10 V2G stations at 7 kW each. That is up to 70 kW of potential import and export into the grid, subject to connection approvals and export limits. There are three assumptions to keep in mind for this modeling. The first one is that both scenarios are based on a long-term parking site. The schedules attached to these electric chargers assume 10 cars arrive on Monday to occupy the chargers and leave at the end of the week. In the first scenario, they plug into smart chargers. In the second scenario, they plug into bidirectional V2G chargers. The second point is that V2G charger costs are a key sensitivity that could change where the commercial break-evens lands. While we expect costs to reduce as demand builds up, in this model, we're just looking at the operational cash flows. Here, the EV charging site receives charging rates from customers, while the V2G site receives revenue from energy arbitrage driven by wholesale price spreads. These two sites face different commercial exposure. The charging-only site is built like a typical C&I load. For the V2G site, we've assumed access to the wholesale energy market and a network tariff to incentivize flexibility, for example, like the ones offered to community batteries in Australia. Now, let's look at the juicy bits, the results. Over a year, the simple EV charging scenario stays financially positive, but we can see network costs bring the revenue down. The V2G site, in contrast, has been able to take advantage of flexibility, and the cash flows are much higher. For regular car parks, charging as a service works because turnover drives utilization. But for long-stay parking, utilization is lower, and paid charging alone leaves infrastructure underutilized. Looking at the interval data from both sites, we can see how the V2G site responds to price spikes and is able to capture daily spreads. Long-stay sites have the perfect edge. The length of stay is predictable, and that predictability is perfect for V2G-based energy arbitrage. And modeling revenue capture also lets you assess what payment to provide EV owners in return for using the cars as flexibility. The parking operator could, for example, offer free long-term parking or even offer an incentive payment to park in a V2G bay. So what is the takeaway of this model? EV chargers in regular car parks can be commercially viable because turnover drives higher utilization of charging infrastructure. But long-stay car parks can unlock more value with V2G because predictable dwell times let you orchestrate charging and export, and because revenue doesn't solely depend on high charger utilization. Modeling these opportunities is critical before investing in infrastructure, and with Gridcog, you can test commercial strategies, utilization assumptions, and pricing options before you invest.